Okay, so why don't we go ahead and get started? I think everybody's here. Jessica Hausman, I guess, was the one who originally had set up this meeting. She can't attend, so Jessica, I know you're on, and I'm going to do my best to honor the spirit of the meeting you set up here. But I'm sure you'll feel free to chime in if I go astray or mislead anyone here. But uh, nonetheless, here I am. Okay, so this meeting was set up. This session was set up. There are a number of different entities, both public and private, that are entering data into the cloud. That's nothing, new or dramatic or exciting, but it's exciting. But with so many different options for putting into the cloud, either through a federal agency, through a commercial provider, through some third party, we thought it was a pretty good idea if we could just get some of the folks together who would talk about, their approaches, to putting data into the cloud. And we have several really wonderful speakers here with us. We have Christy Klein from the USGS. Okay, we have John O'Neill from NOAA. Okay, he's here. We have Katie Baines from NASA. Joe Flasher from AWS. There he is. Chris Linus. Let's see. I don't think you're speaking. And Jeff DLB, I guess, is speaking. Okay. So Chris Linus, are you here? Oh, that's right. That's right. Okay. And I think I got everybody who's participating in the speaker. So these are at least the ones I have slides for. All right. So so I think what I'll do, I don't know, Jessica, unless you have something you want to add here, what I'll probably do is just go ahead and dive into this. I do ask folks, well, one, we're going to try to keep you to some reasonable amount of time. We got an hour and a half, so that's good. But I'm hoping that at least the speakers, and other relevant folks who are interested in this will stick around for a little bit after we sort of formally close the session to help out with the sort of requisite lessons learned and topical points that as does the ease of folks have asked us to record. So I guess barring that, what I'm going to do is I'm just going to start with the order here. And Christy, do you want to go first here? Okay, so arrow. Oh, Baines, Flasher. Let's see. Oh, which one's yours here? What's O'Neill? So that's you. Okay, there we go. That's me. So let's go ahead and get you in presentation mode.
Thank you. Thanks, Dave. All right, so I was actually asked to do this a little bit last minute, so I don't have a lot of slides, and hopefully I won't talk real long. Just to set the stage, if I can get there. So USGS currently has a contract that's for all of USGS, and it utilizes Amazon Web Services as our cloud service provider. So everything I'm going to be talking about focuses on AWS as where the data is located. We currently only have a couple of things out there that are publicly available. One of the most recent was the 3-depth LiDAR data is currently available as part of AWS. So if you went to Earth on AWS, you're going to see that in the directory of public data listings. Coming very soon is going to be the Landsat holdings, and I've actually got over 8 petabytes out there already, and we're going to be reprocessing the collection here real soon. But there are a lot of other possible data that we've been talking about with other USGS entities, to include various water data sets, volcano, earthquake, other types of data sets that USGS currently has. There's nothing out there yet that's publicly accessible, but discussions are ongoing. So we currently have a USGS Data Lake Governance Committee that I'm part of, and we're working on things like what kind of standards are we going to have to put data out in that data lake. For Landsat, we've gone towards things like cloud optimized GeoTIFF and the spatiotemporal asset catalog, or STAC, if some of you were in our previous discussion about that earlier. So those are the kinds of discussions that are going on right now with how we put data out publicly within our data lake. So I'm going to primarily talk about Landsat because I manage those holdings. So, and they're of course the biggest holdings that USGS has. Today we have several levels of data, and each organization has different nomenclature for what these levels mean. And I'm going to give you a little bit of information about the Landsat nomenclature. So we have level 0 data. These data are generally not usable by scientists. They're what goes into processing our usable products. Today, if you went and got Landsat data, you're going to see collection 1, and that's all a level 1 product. Those data are geospatially rectified and radiometrically corrected data, precision terrain corrected, et cetera. In collection 2, we'll also be producing those same products, but in addition, we'll be creating what we call a level 2 product, which is a surface reflectance and surface temperature product. So those are what are coming for the next collection processing. We currently have over 8 petabytes of data sitting out in AWS. That includes our level 0 data as well as all of collection 1. And with collection 2, we'll be adding about 5 or 6 more petabytes. So collection 2, again, not only reprocesses the level 1, but adds level 2 data, and that's a very large data set. So it will be significantly bigger. In addition, Landsat has over 9 million images in its archive. And so there's a significant amount of data, which is why we're going to cloud optimized formats as well as the stack cataloging so that those things can be more easily discoverable. So what is collection 2? Collection 2 will be, again, a complete reprocessing of the archive. We started collection processing here a few years ago, where we wanted data put out to the science community processed consistently across the entire archive, meaning that our calibration is done consistently, that you're getting a consistent set of parameters for ancillary information. And so we intend to continue that with collection 2 with consistent inputs and software versions. What's different from collection 1 is that we'll be improving the geodetic accuracy and metadata. So for example, we've been working with ESA on consolidated ground control point libraries so that if you're using Sentinel-2, for example, and Landsat, once we've reprocessed this data, we'll be using similar ground control points. So you should see better geodetic accuracy amongst those products. In addition, we're improving metadata. If you've looked at any of our products recently, you're going to see pixel level metadata. For example, if you search in our search engines today with cloud cover, you're getting a cloud cover score that's based on the entire scene. But if you look at the pixel level metadata, you can find whether or not an individual pixel is cloudy or not. So that will be enhanced with the next version of the collection. We've also, of course, the major reason for reprocessing is to get to the surface reflectance and surface temperature products that will be done globally. Those products are going to be done in a UTM format today. We've talked about moving to an equal area, but we're just not quite there yet. Maybe in collection 3 we'll get there. Okay, this is an example of what I mean by a surface reflectance product. On the left, you're seeing a level 1 product, and this is a pretty extreme example, by the way. They don't all look this bad. But this one has a lot of cirrus clouds. On the right, you're seeing where the surface reflectance algorithm has taken out that disturbance, and then you're going to see what got taken out so that you see that better radiometric response from the instrument. And in the end, the whole goal of putting our data in the cloud is to get to the point where you can actually use multiple data streams in a consolidated way for data science. And this is something that USGS has been working towards, that we've dubbed EarthMap. Today, Landsat is doing something at a smaller scale with what we call LCMap, but being able to pull in multiple data sources in a common way is really where we're headed towards. And so that's what this is depicting. So we're really just at the beginning, and you should be seeing Landsat coming soon. And we also have a couple other data sets out there right now. And I think that was the end of my presentation. Any questions?
Thank you. Questions for Christy? So I have a couple. Don't run yet. Okay. So let's see. I'll just use it.
I didn't bring the snow, I promise.
Yeah. Okay. Being a former South Dakota person, you know, I blamed her. So, I did have a question. So you brought up Sentinel. Okay, the Sentinel-2 data sets.
Right.
And I do know that there's a harmonized Sentinel Landsat product being put together, which I believe is being managed by NASA.
Yeah.
But are you looking at some means by which you would sort of like interact with those?
Absolutely.
Okay.
Actually, I've been working with them already. They will actually be using our collection 2 data to process that harmonized product. And then the DAC, the LP DAC is who's going to be storing those data, but they'll all be stored in the cloud. So I think there's plans to make those cloud optimized as well as have a stat catalog set against them. So it should be very interactive and interoperable.
So is there going to be an on-prem copy of everything?
Not that I'm aware of for HLS.
Okay,
I think it's
but-
all cloud-based.
But Landsat,
No, it's on my slides.
okay.
Landsat Collection 2 is all cloud-based.
Okay, but not level 0.
Well, I mean, yes, everything except for our mission data will be cloud-based for Collection 2.
Right. The reason I bring up level 0 is that, people can hurt themselves with those data, right? I mean,
So we do offer level 0 access today. It's a restricted access. Typically, when someone comes to us and says they want level 0 data, we try to give them a sample first, and then they usually change their minds. So there's a lot that goes into processing Landsat data to include all the calibration information and the algorithms. So typically what we like to do is give people a sample first before they decide they really want that. But all the level 0 data is currently in the cloud. So if for some reason we did, it would be there.
so is it openly accessible?
Not yet.
Okay. Any other questions? Thank you, Christy.
Yep.
Sorry, I was trying to get it to be out of
Okay, so-
presenter mode, but
We're doing a slight tech adjustment here, so.
I'm not sure why we're not getting it out of presenter mode.
Okay,
So
I
may
think
have
this
to
is
roll
okay.
with presenter mode. It's mostly just for the online people.
Yeah.
But
Okay,
have
so
to
you
see if
online
there's-
folks, we're going to be
hopefully
in
there's
presenter
any
mode, I
embarrassing
think.
notes in there.
I didn't put any, so. Okay, so up next, I'm sorry, I need eyeballs. This is the way things work now. Okay, escape. We have, so I guess, John, you're up next. Let's see if Neil, there you go, and present.
All right, greetings. I'm John O'Neill. I'm the director of the NOAA Big Data Project. I'm just going to talk a little bit about where the project is now, what we've been up to for the past couple of years, and sort of how we work on getting data to the cloud. So where the project fits within the NOAA mission, it's sharing knowledge and information. Aside from all the various other things that NOAA does, the BDP has been really focused on public data access to NOAA data, democratizing access to NOAA data. These are updated slides kindly provided by NCEI, and it basically just shows the situation that we're in and sort of why the Big Data Project was conceived in the first place. If you remember the Jaws movie, it's like we're going to need a bigger boat, so we're going to need a bigger place to put our data. This graph, that line probably extends out through time, continues to go up. We have more and more data, and we need to make that data accessible to the public. So the Big Data Project was conceived years ago to help address this issue. This is a similar slide with a projection. It's all the caveats that go along with projections out in time, but as you can see, it's it's the same scenario. Lots of data, lots of need to make data available, and one of the reasons why this public-private partnership was formed in the first place. Federal data strategy. Data were declared an asset, right? We all know that they're an asset, but formally declared an asset for the government to sort of utilize, work with public-private partnerships on NOAA's open data, partnership with commercial cloud providers, and try to extract more value out of the data that we collect. So the basics of the BDP CRADA phase, which is now over, it started in 2015, and basically it was with Amazon Web Services, Open Commons Consortium, IBM, Microsoft, and Google Cloud Platform. 5 entities that we signed 5 CRADA agreements. So CRADA is a cooperative research and development agreement. It basically said NOAA is going to bring its data, its expertise and support around the data to the cloud. The cloud providers would host the data and make it available to the public free of charge, free of egress. And the experiment was to see whether that was a valuable equation, right? Whether there was enough value in that proposition that people would be interested. So really, with the 3 things that we learned, or some of the stuff that NOAA brought, was NOAA's subject matter expertise was critical to the success of this. Obviously, the power of the cloud platforms was a very critical component. and particularly, scalability, reliability of cloud platforms, which would exceed what our internal systems were capable of. One of the other issues is, I'll just highlight one thing here, so sort of improving NOAA cybersecurity posture. One of the things of rather than having everybody come within the NOAA boundary to get data, we're pushing that out into a more scalable platform and outside of the NOAA boundary. We've also, trying to foster new economic opportunities. We are part of the Department of Commerce, so it's one of our mission objectives. So this is just a representation of how we traditionally would do satellite access, right? We'd have the data at a, distribution point. Everybody would come in, each individual that wanted copies of the data would come in and grab a copy. So we'd have many, many people coming and grabbing copies, multiple copies of data off one of our internal systems. What we did in the Big Data Project is we have a single data broker, which is Cooperative Institute for Climate and Satellites, KICS-NC, that has a new name, but I can never remember it. They would extract one copy of the data and put it out to the multiple cloud platforms. So instead of having many, many people coming in, we extract one copy, reducing the load on the NOAA network and putting it out to the cloud where, you can go to the cloud platforms and you're in a, very scalable architecture. This is just sort of the value ecosystem, as I mentioned, expertise, data, partnering up with the cloud platforms. And I don't talk about this probably enough, but the tooling that exists on these various cloud platforms, we're putting the data where people can use it, where the tools are, where the processing capacity is, so every platform has its various tool sets. So it's right next to the analytical tools that people need. Big lesson learned, data broker, right? So it turned out to be probably what I often refer to as the engine of the project, because, it took the burden of moving data and dealing with the complexity of that off of NOAA, right? This wasn't anybody's, necessarily on anybody's list of to-do things. So by getting a data broker, we removed that responsibility from NOAA. We had an entity that was purely dedicated to just simply moving the data, meeting the needs of the cloud providers, other customers, whomever was requesting data. The advantages for providing access on the cloud, I think are manifest. We've seen that throughout the various usage patterns. It's probably one of the scarcer access. It's not the expertise of NOAA, but the availability of the expertise. But I think what people found through this project was that they could ask a question and they would always, get an answer. If we couldn't provide the answer ourselves, we'd always find out where to get the answer. So I include this, this is an example of GOES data that was being basically accessed on AWS. And, the big spike at the end, the reason I include this slide is that, somebody, started accessing data, went up by a petabyte or so, without really, we looked at this and discovered this retrospectively. If this were a NOAA system, it would probably be likely that we would have had to start throttling or, at least contacting the person and figuring out some way if they were sort of hogging bandwidth. Reason why we're working on the cloud, obviously nobody noticed, there's no big deal, there's no alarm bells going off. So it speaks to the scalability of the environment. And just some examples of some sort of innovative uses of data. The NextRad weather data archive was put onto AWS. Some people were doing some work with mayfly studies, bird migration studies, and it was really made possible by the scalability of the platform. They could do the analysis right on AWS, and they could actually have the whole archive there, in total, without having to try to get little bits and pieces of it out of the NOAA archive. Google Cloud, same thing. Google put GHCN into BigQuery, and we saw, a much more usage than we would have seen in our sort of normal internal systems. I think it shows that if you put it in the right tool and it's the right data set and the right tool, people will come, people will use it. Microsoft has been doing quite a lot with machine vision and fisheries data, with marine mammal identification and some other work along those lines. Just an interesting sort of innovative use of NOAA data. So the CRADA ended in May of 2019. We considered it to be a success, considered it, worthwhile, continuing. So we put out an RFI, and basically the results came back. The basic question was, are people interested in continuing? And the results came back. People said, well, yeah, this seems like it. The users were happy. Cloud platform service providers were still interested. So what do you do after an RFI? You put out an RFP. So RFP went out. It basically codified the CRADA terms into a contract. It was pretty much just an extension, because government needs an authority under which to operate things. So we were no longer in an R&D phase. We wanted to move this operational. So we put out an RFP and signed contracts. And so Amazon Web Services, Google Cloud Platform, and Microsoft are the 3 cloud service providers that signed the BDP contract. The contract is ostensibly it's a long-term contract. It's got base years and option years as part of it. And I always include this slide because if you want to go find the data, that's where it is. And so since you said sort of bring the data, these are actually all the various data sets that are available on the various cloud platforms. So we've got a little bit of everything. We've got lots of radar data, lots of satellite data. We have the National Water Model. We've got NextRad data, as I mentioned. There's a very lengthy list of GOES 16 and 17 satellite products available on, I think, basically all 3 platforms. More data. And we've got some fisheries data, some other stuff, VIIRS data. And I'll point out the last one is emergency response imagery. So we were doing some experimentation of providing stuff in cloud optimized format. So we are providing the emergency response imagery where we can in cloud optimized GeoTIFF on AWS. And that's it, right at the 10-minute mark. Questions?
Thank you.
So Rich.
I was glad you mentioned the cloud optimized GeoTIFF there at the end. It's great that you guys are pushing this data out there. And are there plans, or is there like a group that needs to evaluate like how they could move more of these data sets to cloud optimized formats? Like, I've tried to work with the National Water Model data, and and it's not really in a super friendly format. Is there a way to kind of inject that need back into this program to get some evaluations of some of these data sets in a more cloud up like ZAR or something like that?
Yeah, so we could have a whole session on file formats, as I think we all know. But that said, yeah, there's been a lot of talk about file formats, and it has come down from NOAA leadership. It came down from the DARWIG, who Anna can probably comment on that if she wants, to have more of an emphasis on analysis-ready formats. And that has come from it's now coming from a variety of different places in NOAA. So yeah, I don't know of a specific body that has been formed to, address that. But, the message has definitely come down that, some formats, and I will not name them, are not always cloud friendly, right? I think we all know what those are and know what the weaknesses of them are. So yeah, that message has definitely been received.
Hi, so I might have missed this, but are individual data sets or products, are they available on multiple cloud sources, or is just, the radar data is at AWS and the VIIRS data is at, Amazon?
Yeah, so it simply depends on who's requested what. It may be on more than one, or it may just be on one. Yeah.
Sorry, it's just really online.
So you mean you have worked out with the providers which data sets they want for their own kind of, I assume they're getting something. I know you have a contract with them, but it seems like your model implies that the providers themselves are getting something out of these data sets with respect to, commoditizing them or looking to develop commercial products. So is it the data sets they want, or is it data sets you want to put out to those individual providers?
Not to speak for them, but I think it's more of responding to customer demands from them.
From
So
their customers.
It's not that they can't use them internally, but under the agreements, even under the contract, the data
Right.
have to be made available free of charge. If people want to do processing and other things and pay for that on their platform, that's great.
Okay, so, right, so I see, but that's not driven from NOAA directly, like you guys don't drive that, they drive that? I'm just curious about the model, that's all.
Yeah, it can be either. Really.
Either one, okay.
It's flexible enough that, it can be, if NOAA wants to do, business on the cloud and, the data will be stored for free, the processing or whatever, they can pay for.
Right.
And egress is free if they're paying for the other stuff.
Thank you.
Questions here? So I did have one. I'm gonna use this mic if you don't mind, so he doesn't have to run around so much. So I thought one of the original concepts behind the CRADA was not only just to have the data out there and useful, but also to encourage like maybe commercial value adds and things like that. Are you seeing that kind of usage or?
Yeah, we're seeing a lot of small companies, I don't know, I don't want to steal Joe's thunder, if he's, that are developing products, particularly on satellite data. There's a lot of companies that we've interacted with that, are building products and services on the data. And that's really kind of the whole purpose in the first place. I mean, making the data available, democratizing it so that they have, access to satellite data at a low latency rate. Has enabled them to create products that they probably wouldn't otherwise have been able to create. So that really is sort of the nuts and bolts of it.
Any other questions? Thank you, Joel. So up next we have, let's see, wake up. Oh, here we are. We have Katie.
Good afternoon, everybody. Hope you're all keeping warm and dry. My name is Katie Baines, and I'm going to talk about this topic from the NASA perspective, or at least my NASA perspective. We don't have any open data sets that are sort of really part of that we're jointly promoting right now, but we are moving slowly and surely to archiving our data in the cloud. So who are we? So we are the Earth Observing System Data Information Systems. We sit on right in the middle there in that central rectangle. I think most of you know this. We're responsible for limited processing, archiving, transforming, and distributing data, NASA's Earth science data. We represent several data centers and science investigator-led processing systems, SIPs. So you'll see that we're all over the country doing various things with certain specialties or spheres of influence, as Chris Linus, my coworker, would say. And we have lots of different types of products, from snow and ice data to atmospheric products to crustal dynamics and socioeconomic data sets. We have 12 of those data centers and over 8,000 distinct data collections online. Each of those data collections is curated by what we call a DAC, a Distributed Active Archive Center. They are responsible for providing metadata and providing user support services for the data that they are archiving. And in addition to that, those 8,000 different data collections, we have almost 500 million granules right now that we catalog for searching in our Common Metadata Repository, or the CMR. Much like what you saw in John's slides previously, we too are facing a hockey stick type curve in the future. The two lines here represent archive and distribution and look ahead growth. Oops, that didn't translate well when it was exported, but right now we get about 23 terabytes a day of data coming into our system. With the launch of 2 upcoming satellites, SWAT and ISAR, that number is going to balloon to about 126 terabytes a day of generated data. And some of these data products are not just sitting there never being looked at. Some of them have up to 30x distribution on those products. So the data is coming in and the data is going out, and we are in the middle trying to make sure that everybody gets the data that they are looking for in a timely and free manner. So this is sort of a picture of our current architecture. At the top, starting there, we have a bunch of core services. I've already mentioned our catalog of metadata. We have actually a user profile that we use to sort of track what kinds of users are using our data. We just collect things like email addresses and interests, scientific interests. We have browse imagery services. If you are at all familiar with worldview.earthdata.nasa.gov, I'll plug in for there. They've gotten a lot of press in the news lately related to the Australian fires. Then we also metric all the data that's going out. So we're counting the popularity of this data. This is why we know, like, sometimes data sets have up to 30 times the data distributed that versus the volume that actually are. And we are sort of stovepiped, those vertical rectangles. Each DAC, they do provide the user support services and data curation and quality assurance on all their data products. And they do that sort of, in some fashion, they do cross collaboration, but we are looking to migrate that to a much more of a centralized data lake architecture. Data lake's kind of a buzzword, so I'll use it here, and it means, in our case, we're continuing to provide the data products in the standard formats that they've always been provided in. We will look at different data formats going forward. I know that a lot of people are interested in analysis-ready data formats like ZAR, cloud-optimized GeoTIFF, but the migration activities I'm going to be talking about are really focused on taking the canonical standard products and moving them into a cloud, and then what's next is the really exciting part. So I always say I'm doing the boring part of the work, which is just moving the archives into the cloud. But we will continue to maintain those DACs, those centers of expertise, user support on data products. We'll continue to maintain and steward those data products as we move forward. So this is sort of the vision. This is sort of the now. So the first step that we've been endeavoring, and this work has been in place or been in work since I arrived probably early 2016. So we've been moving slowly but surely towards this. So I have a slide later that really shows that 2020 is going to be a year of a lot of rollouts. I am the project lead on a project called Cumulus. There are a couple of developers in the audience, so kudos to them. But the idea behind Cumulus is creating a unified cloud-based ingest and archive system for NASA's data holdings. This is an AWS-specific project. This is the vision of that one. So you'll see that the purple boxes on the left and the gold boxes on the right are sort of mirroring each other in architecture and deployment. And each DAC will maintain these systems when we migrate them to the cloud, and they'll also maintain their own workflows for ingesting their products and pushing them into cloud-based object store. They will also be responsible for maintaining an operational backup in Glacier of those data products, and we will continue that little blue box that's in the corner. So this is my project, so my project gets the front and center. There's Chris Linus's entire work, which is the really interesting stuff, falls under that blue box of distribution, analysis, and access services. Well, you know, it's ego. So really, if you look at those vertical rectangles there that have squares inside them, if you break them down, they just turn into directed acyclic graphs. I'm a nerd, so I like saying DAG. And it's really a flow chart for people who love flow charts. We really do try to modularize the work that we do and discovering data that's been produced, moving that data, extracting metadata from that data, extracting browse imagery, and then pushing it into our catalogs. Really, we can use that. These are actually screenshots from an AWS project called called Step Functions. And if you want to learn more about what we're doing in that realm, this is the workflow engine that we're sort of using to create our domain-specific uses and migrations. So that's sort of the bread and butter of my work. My counterpart, Chris Linus, has been working very hard on a project called Harmony, which is that blue box that was provided. And here's the elevator pitch for Harmony. So this is another cloud-based system. It's sort of a really elegant middleware. So over the last couple decades, each of those data centers and DACs have produced a unique set of tools that are they're targeted towards reprojecting, reformatting, subsetting, mosaicing their data products. And we want to take those existing tools and sort of put an adapter on top of them and make them invocable through various common APIs. I think that right now, Chris is in an OGC hackathon session to learn more about how we can utilize OGC style services to do this work. So it's really exciting, and it'll allow us to maintain autonomy of services that exist at the DACs and also consolidate some of the things that are more unified and undifferentiated heavy lifting. Yeah, there you go. So this is where we're going once the data gets up there. This is, again, a separate conversation from data formats. This is, again, assuming canonical standard formats that are the science products are already existing in, generally HDF, NetCDF compliant work. But there's a lot of interesting stuff on the horizon as far as keeping a separate copy or temporarily reformatting the data into standard products that are more useful for cloud processing. All right, so this is the exciting part to me. So here's our current status. So I've talked to you about the systems that we're going to be utilizing to do this, who we are, what we've been working on, and what we're facing. Here's the timeline. So we've actually been running several of our services in the cloud for many years. The Common Metadata Repository, that thing with almost 500 million granules that I mentioned earlier, has been working in the AWS cloud for a couple of years now, and provides sub-second granule level search for all of our data products. So that's been a huge success story. It's not the same as running a data archive, but we are running both that metadata catalog and the sort of the web front end to that, the Earth Data Search client, the Earth Data Search, sorry, old habits die hard. And both of these projects are open sourced and being maintained publicly. So it's not just we give you version 10 and never touch it again. It's like all check-ins that are going on in these systems are happening in the public. So that is very near and dear to my heart. So you could go to search.earthdata.nasa.gov or cmr.earthdata.nasa.gov and check those out. They are running in AWS, and Earth Data Search just went to a serverless architecture. So that's really interesting, and that's a whole talk in and of itself on how we've been dealing with a real architecture, fundamental change from servers to a serverless architecture that I am not prepared to give, but it would be a good talk. So as far as data that's in the cloud now, the Global Hydrology Research Center out of Marshall has recently gone into parallel operations as of October 1st of 2019, which means that all of their data, and they're the severe weather DAC, they've got really great lightning data from the ISS that is now being housed in Amazon and archived in Amazon and distributed from Amazon, in addition to on-premise. And going forward, the hope is that we'll migrate to a fully cloud-based archive. The Alaska Satellite Facility has also been working in the cloud for quite a while, doing mirroring of the European Union's Copernicus Sentinel-1 projects. And you can find all of that stuff, which is hosted in AWS, all those Sentinel-1 data products, going to their search engine and ours. So we are in the cloud already. So where are we going next? 2020 is going to be a really exciting year, probably very stressful. So here's all the lines. So you'll see that actually Dave Meyer, our esteemed MC here, is the manager of the Goddard DAC or GESDISC. And they are going to be, over the next couple of months, migrating into parallel operations some of their data products, including MERA 2, which is a modeling product, and the GPM iMerge level 3 data. They're looking to go into parallel operations with that in July. Similarly, the Oak Ridge DAC, which has probably the largest number of data collections, and there are a lot of field campaign data. There is moving their DayMet products, and an upcoming airborne mission, Delta X, will be in the Amazon cloud, also going live in the July timeframe. It's going to be a busy summer. And then LPDAC, which is actually co-hosted with the Aros Data Center that Christy is representing with Landsat, will be rolling out very soon the harmonized Landsat data, harmonized Landsat Sentinel product, aka HLS, and we are really shooting hard for a March 16th or 17th like soft release of that product. So that's exciting. I was just told over lunch today at ESIP that they have done their initial ingest of these data products and put them into the common metadata repository in some of their lower environments. So we're actually making progress towards that goal. And I am not giving up hope that we can make those March dates. And then after that, coming close up on its tail, the Aster data products, the GDEM and a few Modus 6.1 products will be going into the cloud again in that July timeframe. PODAC will be doing an ESA mirror of the Sentinel-6 data products. PODAC is a physical oceanography DAC. They are based out of JPL. I'm sure there are people in the audience from JPL here. And they're doing a whole bunch of fact-finding and data product migrations for that over the next year. And in addition to that, we'll be starting to prototype. So the 4 on the top here, we're really well underway with our activities, planning, system development. And in early March, I think we're going to March or April, we'll be starting to work on this same sort of level of planning with 2 of our other data centers, the NSIDC, or the National Snow and Ice Data Center out of Colorado, and the Atmospherics, oh my gosh, ASDC, Atmospheric Science Data Center. It's exactly what I would expect it to be. And we'll be having discussions with them in the near future to talk about that. All right. So we've got a busy year ahead of us. So what could go wrong? I think it's our job to sort of figure out where this is going to not work long term. And I think it'd be disingenuous to say that this is going to be a perfect process. And no offense to Amazon going forward, but vendor lock-in is one of our most, I think, fraught challenges that we're dealing with. So specifically, how do we move the data? Well, we're really still in the early stages, and we're really only at NASA right now, I think, fully authorized with an ATO to work with Amazon Web Services. I think Microsoft Azure is on the horizon, and we are doing some work to keep data on-prem while we can, but this is going to be a bit of an issue. What if we have to move the data? So these are issues that we're tracking. We're always going to be keeping an operational backup copy in Glacier, but also a level 0 copy of our data in an on-premise facility. More work on that. Am I almost done? All right. So the other thing we have to worry about is what you're using all these Amazon-specific services. What are you going to do if they end-of-life step functions, or what if you have to move to Amazon or move to Microsoft or Google? Every service that we've chosen that is Amazon specific has an alternative in a non-Amazon context. So there are workflow engines, there are queuing mechanisms, there are web object storage facilities at all the major cloud providers. And if you want to roll your own, you can do that with Red Hat, OpenStack, and OpenShift style. And then the only problem is that we've already spent a significant amount of money and time and blood, sweat, and tears on training our staff on AWS. So I think that's a real risk for us. All right, I'm going to roll it up really quick. Sorry about this. End user adoption. So what if you put all your data in the cloud and nobody cares? That's a little scary. I think that both USGS and NOAA have sort of laid the case that they will care and they will come. But we've been spending time in the meantime anyway to start nudging users into that direction. So we've been creating tutorials, scripts, really hand-holding our users into using cloud-based compute to prevent them from downloading and making a bajillion copies of it when not necessary. And in addition, we're also creating a cloud primer for new users who are looking to migrate their workloads into the cloud and as we move our storage there. And I think I'll skip all this stuff, but of course there's money concerns. And if you want to geek out on, how to keep your costs down, because we are paying for all of this, we're paying for the storage, we're paying for the egress, we're paying for the compute, and we've learned a lot over the last 3 years on how the money is spent. And I'll just say, you can save money in the wrong places, and you can save money in the right places. And we've been very diligent about making sure we're trying to save money in the right places. And security is also a problem. I could geek out about that. But I think that's all I have to say. Yeah, sorry, Dave.
Oh, thank you.
No,
Appreciate it.
thank you.
Questions for Katie?
Hey, so this is Jessica, and I do want to mention something. So Sentinel-6 JSON CS is going to be launching in November this year, and that data is going straight to the cloud. So we'll expect data, and after mission checkout, probably be like December or January when data will be available from that.
Cool. I'll update my slides for the next time I present that timeline.
Yes, I noticed it ended at the financial year, so that's why. So I figured you were going with that.
Okay. Any other questions for Katie? Okay, thanks.
All right, thanks.
So I think, oh, we have one. Oh.
This is a comment maybe as much as a question, but one thing we ran into recently with some colleagues at USGS is the issue, not just of vendor lock-in in the way that you're thinking about it, but we have a product that ends at level 2 on the NASA side on one vendor, and they want to produce a level 3 product, but they're locked in with a different vendor. Have you had much thought about how you're going to deal with moving that level 2 product out, or just even thinking about how that happens?
So I think we are providing our data. There is no requester pays in the NASA world, so we are footing the bill for any of these large-scale migrations. However, we are watching what users are doing, and if there are, so some of the metrics that we've seen represent, like, it turns out that 80% of a lot of our data distribution can be traced back to like 4 or 5 specific users, and usually we know them. So I think that we'll have to take that on a case-by-case basis, because we do see it's like, oh, well, they're just obviously watching the bucket, waiting for it to land and copying it over here. There are ways that you can sort of defray that cost engineering-wise, that I'm interested to see how that works. But, you know, we're getting started, but that's a really good point.
Thank you, Katie.
All right.
So Joe, I think we got you next here. So let me pull you up. So we're done with all the federales. Oh, wait. Okay, so let's see. Oh, wrong. Sorry, I got the wrong one here. Okay, I'm back. Oh, here we are. A little bit of a lag time here, sorry. Colorful. Okay, this is a bit annoying. Okay, wake up. No, it's just there's a lag in here somewhere. I'm not sure what's hung up here.
Those are the backups.
Yeah, no, this screen is kind of not responding to me right now. Oh, here we are. I'm going to, boy, this is really annoying me right at the moment. 1 second. Okay, let me just kind of get rid of this one. This is you, right?
So apparently if you get it at the top.
So what's this? Okay. There you go. Right, thanks.
All right, hey everyone, I'm Joe Flasher. I'm the Open Geospatial Data Lead at Amazon Web Services. Quite honestly, I don't know that I really even need to be speaking, because I mean, in a lot of ways, our whole job is to provide the infrastructure to allow our customers to do cool things. You've already heard from 3 of them, and Jeff will be speaking after me. So they're sort of saying anything that I would want to say better than I can say it. However, you're all getting snowed in, so you don't have anywhere else to go. So I'll try to keep it somewhat brief. So yeah, well, here we go. So I mean, in the description, there was a question of what data is available and where it's available. AWS is obviously one place in the cloud where a lot of this data is available. One of the main mechanisms through which we help incentivize that data to be made available is the AWS Public Data Set program. Through that, we work with customers to make high-value data available in S3, which is our object store. We do this for a number of reasons. One is to get it into the hands of our customers who are looking to use it. The other is to figure out best practices so that we can pass those on to other customers who are looking to figure out how to work with various types of data. The public data set program itself is data sort of vertical agnostic, I guess maybe I would say. It is to say that we have data from all different sort of domains. We've got a lot of genomics data. We have a lot of geospatial data. That's what I focus on. We have statistical and regulatory data. We have data from all over various domains. But I focus on geospatial, and that's obviously probably what's of most interest to this audience. If you're looking to find what data is available in AWS, the best place to do that is Registry of Open Data at AWS. I'm too scared to try and switch over to an actual web browser and see what happens. So I just, right before this, I went and did a quick search of just USGS, NOAA, NASA data sets that we have available. So this is what you would see if you went in there and just plugged in USGS, NOAA, or NASA. Jeff, I'm sorry, I didn't put in the lens data, so I apologize. Sorry. So this is just a non-exhaustive list of the data sets that we have available. One thing I should mention is that, and this is sort of, I think, Rich, you alluded to this a bit. S3 is a very powerful distribution mechanism. So the fact that we can get the data in a lot of times its native form into S3 is a great step ahead of trying to get it off of an FTP server. But we can do more, right? And we try to do more. That's one of the main purposes of the public data set program, is to do more. And a great example of this is actually when we initially made some of the Landsat data available, a fraction of the Landsat data available. We didn't just take it in the tarballs that it was originally in. We unarchived it and we turned it into a new format that eventually turned out to be cloud optimized GeoTIFF, right? I still think this is one of our shining examples of being able to experiment with what we initially started with was a petabyte of data, and it's grown to a bit over that now. But we were able to experiment and leverage our customer network to say, like, hey, if we could change the way that we were making this data available to you, how would you like to see it, right? And I always try to be very clear here. This was a conversation that we were involved in, but led by our customers. We're very fortunate in that we have a lot of customers across public sector and commercial sector. But the subject matter expertise was largely coming from them. And we didn't do any, I would say, science changes to the data. We did format changes, right? We're an infrastructure company. Changing formats is a thing that's sort of within our realm of knowledge. Changing byte values is not something that's within sort of anything we do, right? So you won't see a new AWS processing level, right? Like, that's not our end goal here. Our end goal is perfectly illustrated by what Christy was talking about, which is to make it easy as possible for the experts to do their work better and quicker and more efficiently. So we have some focus areas around the public data set program. We have something called Earth in AWS. This is for basically anything related to geospatial. So if you go there, you'll see a lot of our customers talking about how they're using AWS for geospatial stuff. It's really awesome. A number of the people in this room will be featured on there. We also have something called the Amazon Sustainability Data Initiative, which is using our ability to get access and help people work with large amounts of data and focusing on that to try and generate sustainability insights. And so these are sort of ways that we work around the public data set program and around various other Amazon teams and AWS teams to try and help customers. So whenever we're doing this, and I just alluded to this a bit, but and Katie sort of stole this, but I want you to know that I said it first, even though I went second, is to look to remove undifferentiated heavy lifting from our customers. In this context, again, you've already heard this, so look for cloud optimized formats. For raster data, there seems to be a general move towards cloud optimized GeoTIFF. One of the big reasons, as Christy said, is it's not a new format. It's just a set of standards around an existing format. I think this is less certain around n-dimensional data. It's less certain around things like tabular data, although you see things like Parquet and ORC being used heavily. But our goal is to work with different data formats and work with customers around different data formats to figure out what are those cloud optimized best standards. I guess just a quick call out before I forget, there is a cloud cluster within ESIP. I think we were just having a discussion today. I think there's a number of us that are going to try and utilize some of what that offers to have some of these conversations around cloud optimization best practices, storage best practices, those sorts of pieces. So if those conversations are of interest to you, please join the existing, this is not something we're creating, right? This already exists. Patrick Quinn from LM84 sort of leads it up. So please join that, because I think we're going to start trying to use that as a vehicle for some of those conversations. Also, this came up a bit, stack. So you need to have metadata that people can agree on and use. And if you were in the earlier session, this isn't to say that stack is the be all end all of all metadata. It is not. It is specifically not. It is not designed to be. That's why people are actually using it, because it's not replacing all the existing metadata. But when you can get data sets in similar formats and similar metadata, you can help people work across different data sets. If you're looking for an example of this on top of some of the data sets that are made available on AWS, the link there down at the bottom, EarthSearch, is a service that Element 84 runs, which will give you a single API to query across all the data that's publicly available in AWS that has stack metadata. So there's some caveats there, right? But where we can make that happen, so just, I mean, to be transparent, when somebody comes to us with a new satellite imagery data set or some raster data set, we say, will you put that into cloud optimized GeoTIFF, and will you provide stack metadata? If they say no, we don't know it, like we don't kick them out, but we try. So I shared this slide at AGU just a little bit ago, and actually it got some good reactions, so I just want to share it here as well. One of the things that I was talking about there is some of the thoughts that we have when we're sort of going through making some of these data sets available, or working with customers to make the data sets available. And I think the thing for us is we need to figure out where is the right stopping point when you're trying to add value to the data. And you can think of this graph, there are axes here, but this works for a bunch of different types of axes. You could think of it as the interface to the data. You can make very highly designed APIs to access the data, but you're actually going to be cutting out a number of use cases, right? You'll be enabling some others, but you might also be cutting out some use cases. Similarly, if you think of this as a data processing level, right? The more that you're going down the route of data processing, you might be enabling certain use cases, but you're going to be cutting out other use cases. But if you just say everyone has access to level 0 data, I mean, you all were just talking about it a little earlier, like that's not good either, right? So it's a tricky thing, and I think a lot of times it's more art than science to figure out what the right access mechanisms are for users trying to get access to the data and what levels of data. But if you can get that right, then what you're going to see is you can work up to a certain point and you enable a whole user community to come in and build pieces around it. So I just want to give 2 quick examples of where we've seen customers putting data to work in cool ways. Christy actually mentioned some of the LiDAR data that was available from USGS. The cool thing here is this is actually a 2-step slide, right? The first piece was that USGS put the data out there. They actually put it in a requester pays bucket, which means they don't pay any of the egress costs if anyone takes that data out of the cloud. If you're using that data in the cloud, there's no egress cost, right? But if the data is being taken out, you do not pay. It's actually the user who would pay that cost. So they put it out there. And then there is actually a group that came in and basically turned their data, which was a whole bunch of individual collects, turned it into a cloud optimized format and allowed them to see the data in a way that they had never been able to see before, right? So USGS themselves actually were thanking somebody else that came from the outside. I mean, to be completely fair, this is a contractor, so it's not like they weren't being paid to do this, but it's not like they're an unknown entity, right? It wasn't just some kid sitting somewhere. But they allowed them to see their data in a cohesive way, so they could actually see cross collects where they had overlaps, where they didn't have overlaps, where they had data inconsistencies. And they were able to let this happen within the community because they put all the data out there at once in a way that people could work with. Another one, this is work being done by a group called Synergize. This is actually on top of Sentinel-2 data. And so this is a great example of how they're using data at scale to monitor drought conditions or lake, I don't know how much water is in a water body. I think that's probably got a word. I don't know what it is. Lake fullness, I don't know. But around the world, right? And they can do this for a couple of euro a month. A month? I think it's a month, a couple euro a month, which is kind of phenomenal, right? They don't have to pay for the data. They don't have to pay to store the data. They just pay for the small amount of compute, and they're doing this serverlessly, so they don't have a server running all the time. And they're able to monitor drought conditions around the world for a couple dollars, which is, it's crazy, right? I mean, I don't know, it's crazy. So that's all I got. Thank you very much. And I'm here, well, for now, but also the next couple days. Thanks.
Thanks, Joe. We have questions. Mike with the mic.
I know you're talking to an earth science audience, but I noticed on the slide you showed about the different NASA, I think USGS data sets that are available on the web. You did have some astrophysics ones like TESS.
Yep.
And Hubble.
Tab
and I think
Kepler and
there's a
Hubble.
third
Yep,
one,
that's all
yeah.
coming from Space Telescope.
Are those, are there any other NASA discipline data sets like from planetary science or heliophysics that are hosted on AWS?
No, and the reason why I picked them up, honestly, is because I just put in the NASA tag. And when I did so, I was like, oh, these aren't the Earth science ones. And honestly, I forgot that they were there. They fall outside my domain because geospatial is very specifically not astro. I sort of like to say that sometimes because people are like, oh, it's imagery. And I'm like, yeah, but it's definitely not geospatial. So no, I don't think so, at least not through the public data set program. And there's a weird semantic thing that happens here. There's the AWS public data set program, which is a very specific program we have. And then there's public data that's on AWS. And they aren't necessarily the same thing. So if you're talking about public data that's on AWS, there may be some of that. But in the AWS public data set program, not that I know of.
Any other questions? Thanks, Joe.
Yep, thanks.
Thank you. And so next up, we have my co-convener here, Jeff Dula-Beaujardier. And yes, I did pronounce it correctly. Okay, yeah, I worked on that. So let's see. Okay, you all heard that. Here we are.
Okay, so this presentation is actually going to be short. I'm not going to explain why we're putting data in the cloud or anything like that. And I have a longer version of this tomorrow, which goes into some of the more technical detail of what we did. But I'm just going to show sort of the first 2 or 3 on this. But so we've just started putting some data in the cloud. It's called the Lens data. It's the Community Earth System Model Large Ensemble Numerical Simulation. And you can see that photo, by the way, in case you're not familiar, that's NCAR right there, National Center for Atmospheric Research, with the Boulder Flatirons, Mount Meeker in the background. Nice location. Yes, next ESIT meeting in Boulder. No, the next one is in some other town, but yeah, well.
Burlington, Vermont.
Oh, okay. Well, yeah. Okay, never mind. So the CESM Lens data set, this is Community Earth System Model Large Ensemble described in a paper at that DOI, and it's basically a simulation of climate. So these aren't observations, these are model runs simulating climate, both using historical data and then all the way out to the year 2100, assuming what's called the representative concentration pathway 8.5 scenario, which is not only the worst case scenario in the IPCC report, but also the business as usual scenario, as I understand it. It's actually kind of complicated because there's different grids for land versus ocean. There's surface data, there's atmospheric levels, there's ocean levels, there's different time resolutions, there's different time axes. And then there's 40 ensemble members. That's why it's a large ensemble. So they basically ran the model 40 times with slightly different initial conditions, like at the level of round-off error, and then they can kind of compute an average trajectory of the entire ensemble. And it's traditionally kind of hard to access and use. So it's about 500 terabytes of data. Much of it has traditionally been on tape, especially the higher time resolution stuff. 150,000 net CDF files in this kind of directory structure, but it was publicly available from our NCAR Climate Data Gateway. And if you have an account on our supercomputer, you could compute on it without moving it, and that was great, but not everybody has that account. So we've put some of it on Amazon Web Services, not the whole thing, just what we consider probably the most popular subset. In fact, we have room to put a little more if people want variables we didn't put up. I really want to thank the Amazon Sustainability Data Initiative and the AWS Public Data Set Program for the free storage and egress that we have, as well as the collaborators listed here, Anderson, Brian, Joe, Chiefon, and others for actually doing different aspects of the technical work. So we gave this data set a new digital object identifier because it's not the same data set. It's in a different format and it's only a subset. It is listed in the registry of open data that Joe had just flashed up on screen. Right now we got about 70 terabytes. We might increase a little bit, but we've tried to be sure to include some of the daily and 6-hourly data because that was the stuff that was hardest to use. People tended to be limiting themselves to monthly means because they're 30 times smaller than daily data, right? And so that's what they can handle. And we put some of the 3D volumetric data as well as surface fields. And the key use case actually is climate model downscaling to local regions. So we know of at least one commercial company in Boulder that wants to use this as their boundary conditions to do higher resolution model runs at different parts of the world. And that's actually the product that they sell. So conceptually, we've got data on S3. We put it in the ZAR format, which I don't think was really talked about much in this session. It is going to be talked about at our session tomorrow called Pangeo in Action. And I would invite you all to go there, and I'll give you some more details about what we did with this data set, or how we handled this data set, and other people talk about some of these other aspects of Pangeo, including ZAR. We use a thing called intake ESM catalog. So we do not have a stack catalog, which was mentioned in this, which has been traditionally used for imagery. Wouldn't mind making a stack catalog if we understood how to use it for model outputs, which are different from satellite imagery. But right now we have this thing called intake ESM, which basically lets you, see what's there and say, okay, wait, I want the, daily atmospheric temperature for the 21st century. And then you just kind of feed the search result automatically into the X-array library, and it reads the data for you. And then we have a Jupyter notebook that shows an example data analysis and actually reproduces some figures from the official paper. So that's all the detail I'm going to give you. And if you want more, ask me or come to the session tomorrow. I will say that we're working on some future data sets. CMIP6, Anna Prevett and I were just talking about this at lunch. I hope to get at least some of the climate model intercomparison data on Amazon. NA Cordex, that's a regional downscaling experiment that's worked on in my division. I'd like to get that on. And then maybe the GLENS data, which is actually the geoengineering large ensemble. It's similar kind of data set, except very controversial. It says, what would happen if you put some kind of chemicals in the atmosphere to mitigate the effects of climate change? So, interesting stuff. So for further info, please come to the Pangeo in Action session tomorrow, Wednesday, 11 o'clock in the Linden Oak Room. Thank you.
Jeff? Questions for Jeff? Yeah, so I just have a quick one. So you mentioned that this is the lens data is basically a downscaled data set. Okay, and you mentioned some uses of it, but as I recall, like people doing like climate resilience planning and things like that, they didn't want to use complicated data sets. Is this also a target audience for the lens data set?
So it's not a downscaled data set. It's a data set that you would use to start your downscaling.
Oh, okay, so it's front end to downscaling.
Yeah, so it's roughly, let's say, 1 degree resolution on the globe.
Right.
And then somebody says, okay, well, let me carve out a box and use those values as the outer edge of a higher resolution simulation. That being said, there are some overall global estimates. What's the temperature going to be in the year 2100 based on all these simulations, or what are some of the patterns on the globe at a somewhat coarse resolution? Yeah.
Questions? Thank you, Jeff.
Thank you.
So, do you want to take some notes on this next thing?
Oh, for any discussion?
Yeah.
Yeah.
So I want to thank all the speakers again for giving us their take on all this. We do have a bit of time here for discussion, okay? And I did pick out a few points that I'd like to bring up, and I'm going to bring my computer closer to this. So one of the things that I guess kind of comes up, and I guess, Joe, you kind of touched on a little bit in your talk, but it comes up in other discussion. And that's like, public data on the cloud or data on data just somebody has put out there. So I know that there's data that is put out there sort of like programmatically, right? Okay, so Amazon might do something, NASA, NOAA, so on and so forth. But sometimes these data, like say Google Earth Engine would be an example, okay, where just data ends up organically, okay, and there tends to be sometimes a little bit of confusion, as to whether this is actually authoritative data or not, i.e. traceable back to sources, version tracking and all those kinds of things. Now I know that if some user ends up just putting the stuff out on the cloud, that's not your problem, okay? But I don't know, is Kaylin Bugby in here? Or I guess she's not. I was hoping she would be. Oh, she's in the other one. So I don't know. Is there any thoughts about either from the government folks or from the from the commercial providers as to how that might be handled?
Yeah, we used to encounter that sort of in the early days of the BPP. We would get questions about, data sets. Something would come in and someone would say, hey, I noticed this data set isn't being updated. Could you explain why? So we'd look at it and it would turn out that it wasn't one of our data sets. It was just basically something someone had put up there and made their bucket public.
Right.
That has diminished over time as, and specifically obviously dealing with NOAA data. That has diminished over time as more and more, as these public data set programs have expanded and more NOAA data sets, have been available on the cloud. And we would even work with, whomever that individual was to get that data set, taken into one of the public data set programs or under the BDP, to sort of obviate the issues that come along with, uncurated, unmaintained data sets. So at least from my experience, we saw that diminish over time.
Right. So are the data sets you put out there well identified as such then, I guess? So, I mean,
Yeah.
if somebody knew what to look for, they.
Yeah, so
clearly
each,
think,
public data set program has a landing site.
Sure.
And we
DOIs.
create files and descriptions and we have contact information in there. And we always refer back to the source NOAA website for information about the data, but there's always somebody there if you need, there's always contact if you feel there's an issue with the data or if you need some questions answered from a subject matter expert.
So we have somebody back there.
Thanks. I mentioned earlier in the plenary about the Living Atlas of the World that Esri has, and there's some pretty good best practices within that team that when we have hundreds of NOAA data sets, many NASA data sets that are socialized there, I guess would be one way to say it. And they go through a process to submit the data to contribute the data, which includes maintaining the identity of the contributor, and you can see very clearly the authoritative source of who it is, and so they're really responsible for maintaining that data and maintaining the currency of it, the metadata for it. So it's not perfect. I mean, there's some data fall out of get older and not maintained as well. Well, we try to manage that. But I think there are some best practices. That team would probably be a good team to be involved in some of these conversations here in the future. So, yeah.
Thanks. Sir, somebody over here. Needs a mic.
I mean, this idea of putting kind of people putting unofficial quote data sets out there, making them available for distribution. That's not something that's new with the cloud. I mean, right? That's kind of always been a
But it's
concern
easier
that's
to
hanging
do
out
that
there.
now, right?
Well, that's true
Yeah,
to a point.
right.
It is easier, but people have been doing it for years. We
That's
know
true.
a few actually.
Yeah,
So
just a scaling.
yeah.
So let's see, I think Katie left, and I don't know if there are any of the NASA folks here, but I guess I don't know, Jeannie, can you talk about the stuff that Kaylin's doing, or is there somebody from? So this has kind of come up, and I know this has hit my specific data center where we get questions about data sets that really aren't ours. I mean, we are the archive of record for a given data set, but it might end up, because of somebody had a funded project, unrelated to the normal process of putting NASA data into a DAC. And we just have to point out that it's like, these aren't ours. Okay, so I do know Kaylin Bugby is working, I guess, through NASA headquarters right now to work with some of the different providers. I think right now she's working with Google Earth Engine, but I think broadly, looking at some of these more organic data sets and at least just trying to ensure that there might be some kind of, attribution back to sources and things like that. So I don't know, Joe, do got anything like this? Not as part of our efforts. Yeah, right.
Activities that are going on. I'm sorry, I missed you. But so buyers beware, caveat emptor. If you're going to go to AWS on the public sector, and I think that's kind of what Joe was leading up to, you might not get the latest data, but you could go to EOS DIS and get the equivalent products.
Right. But knowing that you can do that, okay? Like you
Yeah.
landed a certain data set, this is the, this has got the mark of approval on it versus
Yeah.
this is something that, somebody from Penn State who's doing a PhD,
Right.
dissertation or something like that
And
put
so
out there
in
for
the
their
other
use.
session, which is on metadata right now, I was kind of looking up the session that Kaylin's running on ontologies and metadata, good first impression. They have some practices that I think are very good.
Right.
They're lessons learned from 20 years of EOS DIS on how to try and improve the quality of the metadata that we're putting out there.
Yep.
So
I hate to bring you all the way over here, but
So Dave, I was just going to ask, I mean, one could check the checksum in the metadata against for instance, CMR, for instance. That's one way of assuring.
yeah, there's a way of
that the
doing it. I
data-
could go in there
Yeah,
and
if
crack
we
open
made
it.
that
Right.
easier to do and
Yes.
more queryable, that's one way of assuring
Right.
that I didn't get it from, but it is the same.
Yeah.
yeah, we spent a lot of time talking about fixity checking in the cloud. And, Katie was talking about some of the risks, and she put some of the top ones that we're addressing. But certainly fixity is very important to us, and each of the DACs has a policy on how they make sure their on-premise
Yep.
data sets are the real ones.
So see, Jeff and then Joe.
Well, I had a different point. If he wanted to make his point first, I wanted to
Okay.
make a
He'll use this one. Okay.
yeah, I'm pivoting.
Yeah, so I think there's a couple of things here. I think, I think our end goal, sorry, I've got like a bunch of thoughts in my head. I think our end goal is to have groups like USGS, NOAA, NASA, ESA, EU, own their data sets in the cloud, right? Like that's the end goal, right? So a lot of the provenance, you have different provenance questions, but a lot of the provenance questions go away. I mean, NOAA's a perfect example of this, right? Because like there are a number of questions on provenance, but it's like you're the ones putting the data in the bucket. Like we are not involved anywhere in that chain, right? Like John slides, like they have a data broker that has a contractual relationship with NOAA and puts the data in there, right? So, and I think some of what John was sort of alluding to is, and I guess I don't, it's not a crime to put a public data set somewhere else, right? So don't take this the wrong way, but it almost makes me think of some of like the piracy things that would happen around like media streaming, right? One of the reasons people pirated a lot of stuff was because it was very hard to get to the data in the way they wanted to. So if you make it easier for people to get to the data in the way they wanted to, then they'll go to the source that you want them to go to, right? But if your preferred mechanism is an FTP server or an API where they're rate limited and they can't get access to run across a whole like 10 years of data, they will go to the place where they can get access to that whole period of data or whatever, right? And I will say, like, I am so happy to see USGS owning all this data because I have been so shocked at the number of people and the scale at which people are using the Landsat data that's on AWS today that is being managed by Planet Labs, right? Like people generally know who Planet Labs is now. They're a satellite startup out of San Francisco. But the Landsat 8 data that is currently on AWS is managed by not USGS, not us. It's managed by a startup that a lot of people don't even know. And it's just because people see a huge amount of Landsat data that they can get unfettered access to. And we'll tell them, I'm not trying to be like sneaky. I'll tell them like there is no SLA here, right? Like Planet does their best to keep it going because they use it for their own purposes. But people will go to where they can get the easiest access of the data. So I feel like I just sort of rambled there, but I guess like the easier that you make it for people to get access to the data, like they hopefully should not be using the random data set from the Penn State researcher. And I think the mechanisms to let them know where you want them to get to it, it's on pages that are owned by the agency, right? So like on a NOAA page, it says, if you want to get this data on AWS, this is the bucket to go to. Or it's sources like we have in that registry of open data. It says, this is the GOES data and it is managed by NOAA, right? And we're very clear when the data is, who the data is managed by. So you can tell if it's managed by a source agency or if it's managed by, like if you go to Landsat right now, it says it's managed by Planet Labs. So we try to be very clear. But.
Christy? I don't know if this detaches. Okay.
So I was going to say some of the same things Joe said, but I mean, today with Landsat data, the authoritative source is only at Arrows, but that data gets pulled into multiple cloud environments, including Google, including what Joe just talked about and other sources. So, I mean, there's no way to stop that from happening, and I don't know why we would. However, I do think it's imperative on the data provider to point at the authoritative source of their data. Now, that doesn't mean Google's still not going to go pull a copy. I just can't guarantee it's going to be the exact same data when they get done doing whatever they do to it. So, you know, I mean, the key is for the user to understand where that authoritative source is and to understand what that data is that they're actually looking at. And I think, you know, it's imperative on the data provider to point at where their source is, but it's really imperative on the user to understand what they're looking at. So, and I don't know any way around that other than maybe the hashing that we put on our data for the user to come back and actually confirm that that's the authoritative source data. The other thing I was going to say about that is the however, if you aren't now looking at the entire product that was hashed or some subset of it, then that all then throws that out the window too. So we're getting to the point where, you know, it's harder and harder to do that even.
So Jeff, did you have a point you want to make?
Yeah, it's related but slightly different sort of direction. I don't want to cut off. I'm kind of disappointed that Katie left because, so as I hear, you know, all the different three agencies talk, this is rattling around in my head for a little while. I'm struck by the different approaches to this and the drivers that everyone takes. So, for example, NOAA seems, if I understand what they're saying correctly, what their approach has been to, you know, we're going to disseminate certain data sets in as many clouds as we can, but the archive is still going to be on a NOAA facility. We're still the authoritative copy. We're keeping that infrastructure. Whereas NASA seems to be driving in a different direction as to we're going to make AWS the archive copy, but that, as Katie pointed out, carries certain risks along with it, you know, vendor lock-in being one, and what if people want to use data in other clouds, use their tooling and things like that. And I wonder if there's a way to scratch both itches by sort of finding some middle ground. And I don't know if anybody at NOAA or USGS or in ESDIS has thought about using something like a co-location facility, because it seems like you could sort of do both things. I mean, if you have a co-location facility, you can make data available in all clouds because it lives like right next to all of them. But at the same time, you can reduce your on-premise infrastructure footprint if that's a goal that you want to do. So
you talk about co-location, you're talking about like interagency co-location?
No. I mean, so there are providers. So all of these big cloud providers, so there are companies out there that build big data center facilities in the regions, and some of the like
Physical.
Microsoft and Amazon, they use those buildings, or if they don't use their buildings, these companies maintain big data centers that are geographically very close, within a few miles, and have very fast connections from their facility to the cloud provider facility. So you can move data in and out very rapidly. But and there's various levels of service they provide. They may just sell you floor space, square footage, or you can pay them to maintain your infrastructure, you know, and then, you know, various points in between. And I haven't dug into this. I'm not an expert on it, so I don't know what the cost benefits look like. But I think it's something that's worth exploring because, you know, there are shortcomings, it seems, with both models that I hear, and I wonder if that's a potential kind of middle road to scratch everyone's itch. Just a thought.
Okay. So I think, Christy, you had something you want to say, but then we probably need to sort of bring this to a close. Yeah, sorry about that.
I know she has more than one mic or something. So yeah, that's actually an issue that we have talked about. From a Landsat perspective, what we call the archive is actually the mission data. And so not the products that the user gets. All of those are going to be right now in Amazon. So, and that's where the authoritative source will reside. our mission data, I'm talking about putting a copy out there, but right now we keep a copy in NARA, we keep a copy on-prem at Aros, and then I'm talking about putting a copy in the cloud as well. Now, the ultimate goal would be, yeah, that you have a authoritative source copy in all the major cloud providers, like what NOAA has done. I mean, that would be great, but we're not at a point where we can do that. However, I think by putting our authoritative source copy in the Amazon cloud, it certainly makes it a lot easier for other cloud providers to get to that data, and certainly faster than what we can provide at Aros even, and we have pretty big networks. So I'm not sure that the accessibility is as big of a deal. And then on top of that, by providing an easier access method, like by using Stack, I think we can provide some of that interoperability where users can point at that resource from Google potentially into the Amazon environment as well. And I think Joe might be able to answer that better. But I do think that we're still dealing with we'd like to think of the cloud as a magical place where everything works harmoniously, but it's not really like that yet. Maybe someday. Even within Amazon, you have multiple regions, and all of our data is going into the Oregon US West region. So if you're in the East region, I guess you're still going to be moving data, or you're going to be coming to the West region to use the data. So, you still have those issues, and I don't think that's a nut we've cracked yet, but maybe someday.
So Joe, then we got to close this off.
Cool. Yeah, I just wanted to say one thing, because we're in a very unique position since we get to support all three of these agencies as well as others. So yeah, definitely they're pursuing different goals, and I think one of the big things is, and I don't mean to speak for all of you too much here, but feel free to correct me, but NASA, at least on Katie's behalf, NASA, USGS are pursuing what I would call more commercial operations. NOAA has gone more of a public-private partnership, and some of that's changed a little bit with the thing that's come, the RFP after the BBP. But some of what NOAA is still trying to do is dependent on a commercial entity wanting to have a part in it, right? So some of it is dependent on us as a commercial entity wanting to host some of that data. That's not true for NASA. Not all data sets are equally useful, right? They may be, I think this is not true, but they may all be scientifically equally as useful. They are definitely not all equally interesting to a commercial entity, right? And so if NASA wants to put up whatever data they want, they can do that because they're paying to do it, right? With different types of relationships, you lose some of that ability, right? So that's just...
Okay, folks, this has really been interesting. I really appreciate the speakers' time here and the audience participation. I think these have been really good discussions. Now, Jeff and I and whoever else wants to stick around are probably going to spend a couple minutes here trying to capture some of this. And I think Jeff might have been busy already in some of this, but I'm going to sort of officially bring this to a close then. Thanks for everything, and see you at the next sessions. Bye. Thanks.